In part 1, I showed you how to graph an exponential function using the 3 points that are always on the graph. And now we're going to do another method, which is evaluate the function for several x values in its domain. So here we're going to plug in a few values. We'll plug in -2, -1, 0, and 1 into the function. So let's start with the first one. We're going to remove the x and replace it with -2. When we do so, it looks like so. And recall, when you have a negative exponent, to make it positive, you flip the fraction. So once we flip that, the exponent is now positive, and that's going to give us 4 because 2 squared equals 4. Next, we're going to plug in a -1. When we plug in a -1, again, because we have a negative exponent there, we have to flip it. So once we flip it, you can see here that we have an output of simply 2. Next, we're going to plug in a 0. And you should know that any number raised to the 0 power equals 1. So we have an output of 1. Lastly, we're going to plug in a 1. When we plug in a 1, that's not going to change the value of it. Our output is 1/2. And now that we've plotted, or we have 4 ordered pairs, now it's time to go plot these points on the rectangular coordinate system. So after plotting these points and drawing a smooth curve through them, our graph is going to look like so. Now let's find the domain and range. The domain, how far does our graph extend to the left and to the right? Well, if you take a look to the left, you have an arrow at the end. If we take a look to the right, we also have an arrow at that end. So that means that our graph is going to go from -infinity to +infinity. Now let's take a look at the range. Range is how high, how low does our graph go. So we can see that our graph does not go any lower than 0. It does not touch 0 because we have an asymptote there, but it gets really close there. So it would be from 0, not including 0, so that's why we put a parenthesis around 0. And then it's going to shoot forever up to +infinity. So our range is from 0 to +infinity.